All right, everybody, we are back with yet another lecture video. So this is going to be the last one that'll go over density. So before we go through density, let's kind of take a peek and review here. So which one of these has more mass? On the right-hand side, we have a ton of bricks. And on the left-hand side, I realize that those really aren't feathers. That kind of looks like a stack of hay. So we're going to call it a stack of hay. So if I have a ton on the right of bricks and a ton on the left of feathers, or hay, whatever we just said. Okay, which one of those has more mass? You would tell me, or at least I hope you would, after pausing this video and taking a couple seconds to think about it, you would tell me that they're the same, right? There's a ton on the right and there's a ton on the left. Remember, a ton is about 2,000 pounds, okay? If there's 2,000 pounds on the right and 2,000 pounds on the left, would that not be the same? Okay. Now, here's another question. Which of these is more dense? The ton on the right or the ton on the left? Take a couple seconds, think about it. All right, now that you've thought about it for just a second, hopefully you would tell me that on the right, the bricks have more density. Okay, so remember, density measures the mass per unit volume. Okay, so not only have we learned about mass and volume, now we're going to add density to the picture. Density is the mass per unit volume. In other words, how tightly packed is a substance? Think of it like this. If I were to take one of these bricks and I were to drop it on the left-hand side of the hay over here, where would that brick go? Would it stay at the top? Would it get stuck in the middle, or would it get close to the bottom? Well, it would probably get pretty close to the bottom, right? And that's because the brick is more tightly packed than all of these hay straws or feathers or whatever you want to call them, okay? So what we're going to do is we're going to talk about density. We're going to talk about some lab techniques that we can use, and we're going to do some calculations in this section. So in terms of density, okay, there is an important equation that I need you to hang on to, okay? For some reason, my arrow is not working here. There we go, okay? Density is the mass per unit volume. That's what this says here, okay? So how tightly packed is a substance? And the density of a material is always the same, no matter what, or no matter the amount, because density is what is called a physical property, meaning it's something that we use to identify a substance. So for instance, if let's say I am big into crypto, okay, and let's say that I'm into buying gold and I'm into buying silver, right? And if I bring in what I think is silver and I bring it to, let's say, a bank and I say, hey, I'd like to cash in this silver that I've been holding on to for a long time that my grandpa gave to me. That's a true story, guys. I have silver from my grandpa. But let's say that I were to bring in silver and they were to say, okay, well, we're going to test the density of it. And they test the density and it doesn't come back as silver. Silver has a density of 10.1. If I bring them a sample of what I thought was silver and it ends up being like tungsten, well, tungsten has a density of 19. They're not the same, right? So density is a physical property. And how we calculate density is we take the mass, the amount of matter, divided by the volume or the amount of space that it occupies. So if I'm looking for density, what I can do is I can cover up density with my finger on this pie chart, and I know that it's m over v. However, if I was looking for mass and I'm given a density and a volume, if I cover up mass, it's d times v. That's what it says here, okay? And lastly, if I'm looking for volume and I'm given a mass and density, I can divide those two, mass divided by density, to get my volume, okay? Take a look at your units down here. We know that mass is always going to be in grams. And if you look at volume, volume could be either centimeters cubed or milliliters. Well, we know that volumes of solids are going to be in centimeters cubed. Volume in milliliters is going to be for liquids. So density can be for solids or for liquids. Okay, so that's super, super important to bring up before we head to our next slide. Density can be in either solid form or liquid form, and we know based on the volume. Okay, so take a look at the picture here. Okay, what we know is that this shows different liquids on the left and then wow, that's funny. Different liquids on the left and different solids on the right. Okay. And take a look at how they're ordered. You can see that water's kind of in the middle here. And then we have the ping pong ball on top and the bolt on the bottom. Okay. So again, I'm having trouble with my clicker here, but the substance with the greatest densities will sink. And that makes sense, right? Because metal is all the way at the bottom. Honey is what we say is super viscous, right? It's super thick. So honey will find itself at the bottom, okay? The substance with the least density will float. And that makes sense, right? Because ping pongs are hollow, right? There's a ton of air inside them. So they're going to float all the way at the top, okay? Which substances have a density of less than water? Well, if you were to look at water, you would tell me that beads, vegetable oil, soda caps, rubbing alcohol, lamp oil, and ping pong balls would all have a substance less than density. How can we tell? Because they float above it. Which substance has the greatest density? You would tell me that it's the bolt or honey because it sinks. It's all the way at the bottom. The mass per unit volume is greatest. So what we're going to do is we're going to practice calculating density. And what I'm going to teach you is the 4-step method. Okay, so how we do this is we do this in 4 steps. The first step, I always just like to label with a 1, okay, is I write what I'm given. So mass is going to be in grams, which equals 365.2 grams in this particular problem. Okay, all it is it's asking me to calculate the density, and it gives me a mass, and it gives me a volume. Okay, so then my volume is equal to 131.3 centimeters cubed. And I'm trying to find my density, so I'll label that as a question. Okay, step 2. What's my equation? Well, density equals m over v. So D equals m over v, or mass divided by volume. Step 3, I plug in my values. So density equals 365.2 grams over 131.3 centimeters cubed. Now, do these units cancel? Absolutely not. So we have to keep them exactly in the form that they are. So with my calculator, what I'm going to do is I'm going to take 365.2, I'm going to divide it by 131.3, and for my answer, I'm going to round to 2 sig figs. So number 4, so I get my answer. Density equals 2.78, we'll do 3 sig figs, centimeters cubed. So there you have it. That is how we would calculate density in this particular problem. Okay, so what we'll do is we'll go ahead and we'll jump to this one. Okay, this question says you find a silver liquid at home. You think it could be mercury, which is labeled as Hg, which has a density of 13.5 grams per milliliter. And what's interesting is mercury in its natural state is actually a liquid. It's a metal, but it's a liquid. So kind of cool. In the laboratory, you determine that the volume is 5.7. So for my first step, I always write what I'm given. So the volume, 5.7 milliliters. Okay, and the mass is 76.95 grams. Okay, now it tells us what the density is, but we're trying to identify if this is mercury. Okay, so what I'm going to do is I'm going to leave this blank to determine whether it is mercury or not. So I'm going to try to find density again. So step 2, write my equation, which we know by now, hopefully, is mass divided by volume. Step 3, okay, I plug in the values. So I have 76.95 grams, all over 5.7 milliliters. So in my 4th step, what I do is I simply divide those values. So I'm going to take 76.95 divided by 5.7. And look at that. What do I end up with? I get 13.5 grams per milliliter. So is this particular silver liquid that I found at my house mercury? You would tell me, yes, it absolutely is mercury. Okay? So at this point in time, what I'm going to do is I'm going to pause this video or I'm going to ask that you pause this video, better yet, and you're going to tell me the answer to this question using our four-step format. And so what I'm going to do is I'm going to give you space to do that. So go ahead and pause this video. And when you're ready to check your answer with what I get, feel free to do that and unpause it here in a second. All right, so hopefully you were able to come up with an answer. And so what I'm going to do is I'm going to work pretty quick here. So I know that the density is 2.7 grams per centimeter cubed, and it gives me a volume, 12.993 centimeters cubed, and it's asking me to find the mass of this sample, okay? So now, I look at my equation over here, my pie chart. I know that mass is above D and V, so I multiply them. So step 2, I find my equation. So mass equals D times V. So step 3, okay, I'm going to plug in my values. I might run out of room here, so I apologize. I might abbreviate grams per centimeter cubed. And I'll multiply it by 12.93 centimeters cubed. Okay, and when I do that, I get a mass. I'll take my calculator, 2.78 multiplied by 12.993. And what I get is I'm going to round to 3 sig figs. So I'm going to take 3, 6.1. And the units, centimeters cubed is actually going to cancel. So that leaves me over with grams. So my answer is 36.1 grams. So go ahead, and if you want to, I have 3 more practice problems that we'll take care of in class, maybe as some startups throughout the week. But if you want to, feel free to do those in your free time, go for it, okay? But anytime that you are given 2 of these values, you can always calculate for the other.